Hey guys, and welcome again to the video. Now we are through with 75% of our data science journey. We have covered 3 modules out of 4, and this will be the last module, that is advanced modeling. Now I really hope all the sessions so far have been productive for you. I tried my level best to make it easy to understand so that even if you don't know anything about statistics, you can benefit from it. Now if you haven't checked the earlier modules already, I highly recommend you to do so. It's a complete course and you'll surely benefit from it. Also, I have put up a PDF in the description that explains the entire structure of this course. So do refer to it to understand how the course is structured. And now as usual, let's quickly refresh what we have covered so far in the 3 modules. So the first module was about basic statistics. Here in the first section, which was about fundamentals of statistics, we discussed about data, scales of measurement, population and sample, measures of central tendency, measures of position, measures of dispersion, and few other important terms such as covariance, correlation, outliers, noise, and standard error. Then we moved to second section of our first module where we talked about probability and distributions. We covered all the topics shown here on the screen. You can have a look at it. I'm going to skip it. Then we moved to third section of our module 1 where we discussed about the statistical hypothesis and its testing. We learned about statistical significance, type 1 and type 2 errors, and finally the types of hypothesis testing. So that was module 1, and then we moved to module 2. So in this module we were introduced to R. Here we learned about R and the reasons for using it. Then we talked about the concepts such as data structures and types of data structures and so on. And then in the next section we did assignments in R. So we did total 6 assignments in this section, and with this we wrapped up our second module. Now in the third module we started learning about modeling concepts. I think this was the most awaited and exciting part, because here you started getting the hang of the real life problems and developed models. Nevertheless, previous modules formed the foundation and were equally important. So in this module we first set the context by learning the background of modeling. Basically, what is modeling, what is statistical learning, the difference between regression and classification, and how to assess model accuracy. Then we started learning different algorithms in details, such as linear regression, logistic regression, decision tree, naive Bayes, multinomial and ordinal logistic regression, and resampling methods. Then we built models using algorithms such as simple linear regression, multiple linear regression. We also did regression diagnostics and variable selection. Then we built decision tree for both regression as well as classification. And then we did multinomial and ordinal logistic regression. And finally we did cross-validation. So we actually covered a lot of stuff. So I highly recommend you must go and check it out if you haven't done already. Now let's move on and see what our fourth and final module will look like. So again, there will be only one section in this module, Advanced Modeling Concepts. And the section has been divided into the following topics. We will start with discriminant analysis. Then we will cover clustering. Then we have principal component analysis. After that we will cover support vector machines. Then we have association analysis, also called as market basket analysis. Then we will cover neural networks. And finally we will wrap it up with time series. So guys, this is gonna be a real fun. This really covers everything. Once you are done with it, you really have touched upon almost all the available algorithms. I mean, there is still a lot to learn, but these are some really powerful algorithms being used in the industry. So without wasting our time, let's start with our first topic. So in discriminant analysis, we will first see what is discriminant analysis. After that, we will see the difference between linear discriminant analysis and quadratic discriminant analysis. Then we will go into the details of LDA, how does it work, and then we'll see how QDA works. After completing the theory part, we will as usual implement it in R through an assignment. So that is how we will be proceeding in this section. So let's see what discriminant analysis is. So discriminant analysis is a classification approach similar to logistic regression. Now the question is, why do we use it then? Well, it has few advantages over logistic regression. Let's see what are those advantages. Firstly, if you recall, we discussed in logistic regression that if there are more than 2 classes of the response, then we prefer other techniques over logistic regression. So discriminant analysis is a popular approach if we have more than 2 responses. Now if n is small and the distribution of the predictor x is approximately normal in each of the classes, then the discriminant model performs better than the logistic regression model. Also, when the classes are well separated, the parameter estimates for the logistic regression model are surprisingly unstable. Discriminant analysis does not suffer from this problem. So that is how it is. We don't have to go into the why of it. Basically, highly learned statisticians have done this for us already, and we just have to believe them and move on. Now that it is apparent that discriminant analysis has an edge over logistic regression, whether you understood it or not, it's a secondary thing. But that is a fact. So let's take it as it is and learn it now. So we have two types of discriminant analysis: linear discriminant analysis and quadratic discriminant analysis. Linear discriminant analysis is used when the variance-covariance matrix of all the classes is same or does not depend on the population from which the data are obtained. Now what does this mean? This was a bouncer straight above the head. So let's understand this with the help of a graph. So if you look at the graph, we have shown two classes, one with circle and the other one with triangles. By just looking at it, you can see that variance is consistent within the two classes. Hence, we can easily use a linear decision boundary here. Now let's look at the second figure. Here we can see the variance of the data within the two classes are not same or consistent. Here if we use a linear decision boundary, we will end up with a poor model, because a linear boundary will not be able to discriminate between the two classes. Thus, in such cases, we use a quadratic decision boundary. So that was the difference between LDA and QDA. Now obviously you cannot look at the data every time and tell if the variance-covariance matrix is same or not. So for this purpose, we use two tests called box-M test and Levine test. Now we don't have to go into the details of these tests. We will let the software do it. Just understand that these two tests are used to check if the variance-covariance matrix are equal or not. Also, LDA and QDA assumes that data is Gaussian. That is, it follows normal distribution. Now let's see how does LDA works. Although R will do this for us, but we should understand this to know the concept. Suppose we have our data as shown here. So we will use a decision boundary to discriminate between the two classes. But the question is, how do we get to this decision boundary? So we project the data onto a new plane such that we maximize the distance between means of two classes and minimize the variation within each class. So what does this mean? Now as you can see, we have projected the data onto a new plane called LD1. This will always be one less than the number of classes. We get this LD1 using the coefficient of discriminant. We will see this in detail in the assignment part. Okay, so now if you look at the data and the axis here, we can see that the mean is maximized between the two classes and also the variance is minimized within each class. So we will choose that decision boundary which will help us achieve this. So that was just to explain how things work in the background. Mathematically, in LDA, we compute discriminant scores for each observation to classify which class the response variable belongs to. Suppose we are working on loan defaulters and want to classify individual to defaulter or not defaulter categories. So our goal is to maximize the linear discriminant score, which can be calculated using the formula shown here. The entire function is called as linear score function. Delta x is the estimated discriminant score. Mu is the average of all the training observations from the kth class. Sigma is a covariance matrix that is common for all classes. Pi k is the prior probability that an observation belongs to the kth class. Now as this formula looks a bit scary, so obviously we are not going to remember it. We will let R do the calculations. Now once the score is calculated, classifier assigns an observation to the kth class for which discriminant score is largest. So that is how linear discriminant analysis works. Now second we have quadratic discriminant analysis. So we saw earlier that in QDA, variance-covariance matrix is not constant. QDA assumes that each class has its own covariance matrix. In other words, the predictor variables are not assumed to have common variance across each of the k levels in the response y. The formula for calculating the discriminant score is modified as below. Here summation k is the covariance matrix for kth class. That is the only change in QDA. Earlier we had this covariance matrix common for all the k classes. Now we have individual covariance matrix for all the classes. So that is how we calculate discriminant score in QDA, and then rest of the process remains the same. Alright folks, that was all from discriminant analysis. So let's quickly revise what we have covered so far. We first understood what discriminant analysis is. Then we saw the difference between LDA and QDA. Then we saw how LDA works, wherein we saw how LDA chooses the decision boundary and what is discriminant score. And then lastly we covered QDA. Now let's move further and do an assignment on LDA and QDA in R.